Welcome back to my channel, and today we're going to be talking about vertical asymptotes and horizontal asymptotes. Before we get into this content, don't forget to smash that like button, subscribe, and hit that notification bell to keep getting this great calculus content. So we're going to be starting with some reminders. When we have something like a limit problem where we get an answer like a number over 0, that means that we are going to be approaching a positive or negative at infinity. When we get a number over infinity, that's going to be going towards the number 0. On the other hand, if we flip that around, we're going to be going towards positive or negative infinity again. Indeterminate form is that 0 over 0 or that infinity over infinity, so we do need to kind of keep that in mind. If we do find ourselves with limits where we are dividing by 0, we may want to determine what's actually happening there, if it's going towards positive or negative infinity. Generally speaking, we want that when we are dealing with a multiple choice problem and we need to be specific with our answers. So we're going to look at these two graphs first, and these graphs are going to help us with our limits. So we are going to kind of look at what's going on in this function. So if we look at this function, I can see from the graph, but also the function, if the denominator were to equal 0, it's going to cause a vertical asymptote because there's nothing else in the numerator. If I were to put 1 into this function, that's going to give me this vertical asymptote here. As I am approaching from the left, we are going down towards negative infinity. If I am approaching from the right, we're going up to positive infinity. Because those two are not the same, they are going to not be equal to each other, which means our overall limit does not exist. So we could write does not exist for the top two, but sometimes we need to be a little bit more specific, so I'm going to go ahead and use negative infinity and positive infinity. On the other hand, with this one over here, if we look here, if we were to plug in 1 again, we're going to have a vertical asymptote right here. The big difference being this one has a squared in the denominator, meaning that whatever we get, we are going to be squaring it, making it positive. So when we look here on the left and right side, our function is going towards the same values, those positive y values. So when we are on the left side and the right side, we happen to have positive infinity as our limit. Because they are the same, I can go ahead and say that positive infinity is my overall limit. So this brings us into vertical asymptotes. So for what we are talking about, we just kind of need to remind ourselves some information about vertical asymptotes. When we see a limit and we get an answer of us going towards a specific x value on the left or the right side, and it equals infinity or negative infinity, that is always going to be a vertical asymptote. So if we apply a limit and we get positive or negative infinity, that means that it is going to be a vertical or horizontal asymptote. So when we look at these problems, we need to think about both the left and the right, because sometimes we get different infinities, which will tell us about something overall. So I'm going to look at the left limit first. So the limit as x approaches 1 from the left of 2 divided by x minus 1. So when we think about this as a problem, if I were to plug in 1, this would be 2 over 0, meaning that we are going to get that over 0, which is an undefined number. And we would normally just say that this is a does not exist case, which is true. But we can also kind of look at this a little bit more in depth. So if we look at this as it approaches the right side or the left side, we're thinking about numbers slightly less than 1. So if I have like 0.9 and I subtract 1 from it, this is going to give me a slightly negative number in the denominator. And as I get more and more close to 1, our numbers are going to be getting more and more negative. So because of that, I know that I can be looking at this and it's going to be going towards negative infinity. So now I want to think about the right side. If I were to plug in a number slightly bigger than 1, we're talking about like 1.1. Well, 1.1 minus 1 is going to give me a positive number here this time, and as I get closer, it's going to make it more and more positive. So if I were to look at this overall, this is going to give me a positive infinity. Because they are not the same, I know overall this limit does not exist. So we're going to look at this one. We're going to look at 3. If I were to plug in 3, 3 squared is 9. And if I add 3 to that, that gives me 12. But I'm also going to be subtracting 12 from here, so I know the top goes to 0. If I plug in 3 on the bottom, we get 9 plus another 6 plus another 6. So 9 plus 6 gives me 15, minus 15 is 0. So this gives us 0 over 0, which means that we could get an answer, or we might have to try something else. So first thing we could probably think of would be finding our factors. So our first one, I have an x squared. I'm multiplying to get to positive 3 and adding to get to negative 4. So that tells me both of mine are negative. So negative 3 and negative 1 makes sense. On the bottom, I have 1 that I am multiplying to get to negative 15 and adding to get to 2. This means I have a positive and a negative. And our bigger number is positive. So 3 times 5 will give me that 15. 5 minus 3 will give me 2. So if we look here, we have a x minus 3 and an x minus 3 here. If I cancel that out, we get the limit as x approaches 3 of x minus 1 over x plus 5. If we were to then plug this in, we get 3 minus 1 over 3 plus 5. 3 minus 1 is 2 over 8, which gives us 1/4. So one thing that you need to notice here is that we didn't get an answer of infinity, but that means that this is not a vertical asymptote at 3. What this means is that we have a hole at 3 because we got that 0 over 0, and we could kind of cancel something out to give us this value. If I were to have looked at negative 5, on the other hand, we would see that that would make this denominator equal 0, and there's nothing I can cancel out in the numerator, so we have a vertical asymptote at negative 5. When we were looking at this one over here, we got does not exist, and we got these asymptotes, which means we have a vertical asymptote at x equals 1.